Hello, my dear students. Happy morning to all, and I welcome you all back to my channel on Electromagnetic Induction Part 2. Today, we are going to see about a motional EMF, especially in electromagnetic induction. Further, it can be divided into two parts. One is about a motional EMF, another one is about a self and mutual induction. Now, see this one motional EMF, which is often appears in EAPCET and NEET problems and most important problem, and very few formulas are there. With that formulas only we are going to crack all the problems here. Whether you are preparing for a NEET examination or even for the EAPCET examination, or even if you are very curious to know about electricity and magnetism, how it both work together, how we are going to see this one. This is a key term and a key steps which is important over here to see this one. In a simple terms, what I mean by motional EMF, suppose if you consider about a conducting wire which is placed in a magnetic field, once you are going to drag or moving the conducting wire or even a conductor in a magnetic field, that creates an EMF that we call it as motional EMF. Now this one we are going to see about how the motional EMF is works. We can see one by one, step by step, we can see this one detail. Now we are going for the problem. The first problem on motional EMF. This one, the wingspan of aeroplane here is 20 meter. It's flying in a field where the vertical component. See here, they have given the vertical component of magnetic field is 5 into 10 power minus 5 Tesla here. They haven't specified on Gauss, they have specified on Tesla. So you can directly use this one. With velocity here is 360 kilometer per hour. See here, kilometers per hour. Usually we used to have meter per second, but they have mentioned about kilometers per hour. Now the potential difference produced between the blades will be. Now in that case, what I'm going to mention here is potential EMF, that is EMF induced, that is motional EMF. In that case, E is equal to B vector, and this one B vector dot L vector cross V vector here. So only changes on the length and velocity. From this one, this is cross product here. So this one here is VLV sin theta, and here already they have mentioned this is vertical component, so that theta here is 90 degrees. So what we are having here is only VLV, since sin 90 degree, here is one value here. Now substitute this one, all the values. What is the motional EMF? In that case, B value here is 5 into 10 power minus 5, and the length here is 20 meter, and velocity here is 360, that is kilometers per hour. Kilometer, you just convert this one in meter, that is 1000 here. Hour here is convert this one in second, that is 3600 second. Now just cancel this one. So what you are going to have here is, I just mention again, see here, 5 into 10 power minus 5, and this one here is, you just cancel this one, 36 and 36. This is for 10 times here, 20 is there, and even you are having 10 into 10 100 is there. So what you are having here is 5 into 20 here is again 100 here, 100 into 100 into 10 power minus 5 is there. So what you are having here is 0.1 volt here. So answer in this case, problem, this is old question paper problem. A small piece of a metal wire is dragged across the graph between the whole piece of magnet in zero point 0.4 seconds. Now I just show you here. Now you just consider a small piece of magnet. I just draw here. Now this one, a small piece of magnet, and in this magnet a small hole over here. On the small hole, you are going to drag a wire in this hole for t equal to zero point 0.4 seconds. In 0.4 seconds, you are going to drag the wire. Now, once you are going to drag the wire, what's happening here is the magnetic flux between the whole piece is known to be 8 into 10 power minus 4. So that what about the induced EMF? Now, according to Faraday's law of electromagnetic induction, the induced EMF will be equal to the induced EMF I just mentioned here, that is epsilon. Epsilon here is the rate of change of magnetic flux. Now this one, the changing magnetic flux what they have given here is 8 into 10 power minus 4, and the time period here is 0.4 second. Now how you can mention here is 8 into 10 power minus 4 divided by 4 divided by 10. Now you just cancel here, this is 2 times. Now 2 into 10 power minus 4, that denominator will become a numerator over here, that is 10 over here, that is 2 into 10 power minus 3 volt, that is about induced EMF. So answer here is a copper disc of radius 0.1 meter is rotate about its axis, natural axis, with a 10 rotation per second in a uniform magnetic field 0.1 Tesla. See, I just show you here. Now, you just consider about a copper disc. Now, this is about the copper disc over here, about its axis. This is about the rotational axis, which is having a radius here is capital R. Now, see, this is about the rotation axis, and here rotation what they have given here is 10 rps, 10 rotation per second, and the uniform magnetic field which is perpendicular to the field. See here, which is perpendicular to the plane. So here this is about the magnetic field, and this is about the rotational axis, and perpendicular to the plane they have given the magnetic field here is 0.1 Tesla here. Now, what they are asking here is EMF induced. See, in this case, I just show you the theoretical part of this one. See here, in this one, if the rod of length is L, see here length, here radius. See, this is about the length, here this is about the radius. Now this is rotating 10 rotation per second. So which is rotating 10 rotation per second. Here similar like this, which is rotating along here. So they have given a angular velocity and the magnetic field. So all the cross mark that is perpendicular to the rotational axis. For this one, EMF here is E is equal to 1 by 2 BL square omega. Now similar concept we are going to use here. See, EMF, induced EMF, I just mentioned this one as E is equal to 1 by 2 B R square omega here. Now from this one I just mentioned here, omega value here is 10 rotation per second. So 10 rotation, one full rotation means that you can mention as 2 pi. 2 pi here is one full rotation. There are 10 rotation per second. So what you are having here is 20 pi rotation per second, that is about omega here. Now substitute all the value, 1 by 2 into B value here is 0.1 Tesla, and R value here is 0.1 square here, into omega here is I just mentioned as this one here is 20 pi here. Now you can cancel this one for 10 times. So here is 0.1 into 0.01, that is 0.1 square into 10 pi here. So if you cancel this one, this will become 1 here. So what you are going to have here is pi into 10 power minus 2 volt, that is about a rotational EMF in this case. So answer here is next problem. This is similar like a previous one. You can understand this one little better. See here. Uh, this one little detail explanations we can see. A wheel with 10 metallic spokes, each 0.5 meter length. So each length is 0.5 meter, and there are 10 metallic spokes here. Is rotated with the speed here is 120 revolution per minute. Now see here, 120 times it can be rotated for 60 seconds. Then in a plane of normal to the earth magnetic field. So earth magnetic field they have given 0.4 Gauss. See here, this is Gauss. You have to convert this one in Tesla, that is 0.4 into 10 power minus 4 Tesla. See here, they have given 1 Gauss here is. Now at the place, what is the induced EMF between the axial and the rim of the wheel? Now similar concept what we have seen the previous one. See, first we have write the given data. What are the data has been given here? See, first here radius what they have given here is 0.5 meter here, and the next one the frequency what they have given here is 120 revolution per minute. So 1 minute there are 60 seconds. So I just mentioned here 120 revolution per 60 seconds. So that means there are 2 revolution per second. That means in 1 second the rim will be rotated twice. That's all. That is the thing here, frequency. Now, angular frequency, how you can mention here is omega is equal to 2 pi f or even 2 pi nu. Similar concept here, 2 pi into frequency what you have given, 2 revolution per minute. So what you are having here is, that is your angular frequency here is 4 pi revolution per second. Now this one, rotation, angular velocity. See, from this one I just mentioned here. Now here B value what they are given, that is earth magnetic field here is a 0.4 Gauss here. That one you can mention like 0.4 into 10 power minus 4 Tesla. And EMF induced here, E is equal to 1 by 2 B R square omega here. Now 1 by 2 into B value 0.4 into 10 power minus 4 here, and a R value what they have given here is 0.5. 0.5 you can mention like a 5 divided by 10, twice 5 by 10, like that you can mention here, that is 0.5 square into omega what they have given here is, that is 4 pi. Now you just cancel all the things. See here, you can cancel it here. For this one here is uh, 0.2 here, and even this one 0.25 into zero point 0.2 here is, these two will be 1 here. So what are the things is there, 10 power minus 4 is there, 5 into 4 20 is there, 20 into pi and divided by 100 is there. Now one cipher you can cancel here. So this one if you cancel it, and from here this one pi here is 3.14, 3.14 into 2 into 10 power minus 4 and divided by 10 here. The similar one 6.28 into 10 power minus 5. This one numerator will become, so denominator will become here 10 power minus 5 volt here. So EMF induced in this case. So answer here is, this is the important old question paper problem. So I have mentioned in all the cases, I have mentioned this one important questions over here or here, like that I will mention here. See, two rails of a railway track are insulated from each other. See, two railway track rails of railway track. See, one and two rails over here, and both are insulated, and the distance between this one they have given as 1 meter length. See, now this one uh, and the ground are connected with a millivoltmeter. See, on this railway track ground which has been connected to millivoltmeter here, in between the tracks over here, what is the reading of voltmeter when a train, reading of voltmeter is about a volt, right? That is about the EMF when a train moving with the speed on the track, train moving with the speed of 18 km per hour, given that the vertical component in this case theta is equal to 90 degrees. So sin 90 here is 1 here. Now see, in this case theta is equal to 90 degree, and a sine of 190, sine of 90 degree here is 1 here, and vertical component of magnetic field they have given, and the rails are separated by the distance they have given, that is L value. From this one E is equal to BL into V sin theta here, BLV sin theta here is 90, so this answer is 1 here. So B value here is 0.2 into 10 power minus 4, and L value here is 1, and velocity what you have given here is 180 kilometers. Kilometer you can convert this one, meter here is 1000, per hour here is in second here is 3600 second. Now we just cancel here. So what you are having here is, now this one I just mentioned in a different color so that you can understand here. So here is this is 2 times here. Now this is 10 times, right? From this one, see here, even you can cancel over here. So that is zero point 0.2, and this one will be cancelled here for 0.1 time. That means this one and this one combined together 10 power minus 4, and zero point 0.1 you just multiply here, that is 1 here, 1 again 1, and even one more 10 is there, right? So this 10 is there, right? See, from this one what you are having here is 10 power minus 3 volt. So that is EMF in this case here is 10 power minus 3 volts. Answer here is Next problem here. A coil has 1000 turns, n value they have given, and area here is 500 centimeter square. See, centimeter we have to convert this one in meter, so 10 power minus 2 whole square will be there. And the plane of the coil is placed at a right angle. See here, right angles to the magnetic field is 2 into 10 power minus 5 Weber per meter square. Now this one, in that particular area magnetic induction they have given, the coil is rotated through 180 degree for time 0.2 seconds. So what they are asking here is average EMF induced in the coil. Now for this one, let me write down here EMF induced in the coil. In that case, see here, EMF induced in the coil as per the Faraday's law you can mention here, that is d pi by dt. Suppose if it is a big changes, small changes means d pi by dt, maximum changes means delta pi by delta t. Now the time variations they have given, t value they have given here, changing time over here, and the angle here is 180 degree here. Average EMF they are asking here. For the first case I just mentioned here, that is pi 1 initial at 0 degree. The value here is nba cos theta here. So theta, in that case theta is equal to 0 degree here. So cos 0 here is 1. So answer in this case nba into 1. So here answer here is nb into a for the first one. Next one, after 180 degree of the rotation, so pi 2 here is nba cos of 180 here. Now I just mentioned as cos 180 degree. Cos 180 here is minus 1. So what you are having here is nba. Now minus NBA here. Now the net flux changes will be, so net flux changes I just mentioned here as net flux change here is, that is delta pi here, that is nothing but pi 2 minus pi 1 here. Now from this one, so what you are having here is minus NBA and minus of NBA here. So what you are having here is minus 2 NBA. Now this one, so magnitude of EMF, average induced EMF, you just consider about magnitude of EMF. In this case you just put here delta pi by delta t. So in the modulus, negative will become positive here, 2 nba, and divided by t here. T value already you know this one, 2 into number of turns here is 1000 here, and b value here is 2 into 10 power minus 5 is there, and area here is 500 into 10 power minus 4. So centimeter square, that is 10 power minus 2, and divided by whole power whole square 10 power minus 4 is there, and time here is 0.2. Now this is a simple term, you just cancel here. This is for 0.1 time. 0.1 will become, this one will become plus 1 now. See, or even you can mention like 1 by 10. So here it will become plus 10 now. Now you just cancel here. So once you cancel this one, what you are going to have here is 10 power minus 2 volt will come. So but they are asking in this one, they are asking about millivolt. Millivolt in this case, I can mention this one 10 by 10 into 10 power minus 2 volt here. So from here what you can mention here is 10 into 10 power minus 3 volt, that is 10 millivolt. So answer in this case. Coming to the next problem, a coil having area, that is A naught, is placed in a magnetic field, changes from B naught to 4B naught. So magnetic field has been increased in a time interval of t. Now if magnetic field is increased, what about EMF? EMF induced in the coil will be, now actually what happened here is the EMF, see, magnetic field is increases, EMF should be increases. I will tell you here the EMF formula according to the Faraday's law, E is equal to d pi by dt here. Now this one from here, pi is equal to b dot a. You can ask this one, how come this formula has come? See here, for example, in case of b, that unit here is, you can mention here, that is Weber per meter square. Hope you remember this one, the previous problem. You can see here magnetic induction here is Weber per meter square. Weber is nothing but the magnetic flux. Meter square is nothing but area here. So B is equal to pi into A. From here pi is equal to B dot E. Now you just go to the formula here. Phi is equal to B dot E. So I just mentioned here d by dt of BA. Now the changes here is magnetic field or magnetic induction is going to change. Area is not going to change. They are given the area here is A naught here. So d by dt of only changes here is B here. So that is equal to the EMF. Now from this one I just mentioned here. So A naught into what are the changes? Final minus initial here. Final here is 4 B naught. Initial here is only B naught here, and divided by timing they have given as t only. See from this one what you are having here is A naught is there. This is 3 B naught divided by t. So answer here is 3 A naught B naught divided by t. That is induced EMF in this case. So answer here is problem. If a coil of 40 turns, N value given, area A value given is suddenly removed from the magnetic field, it is observed that a charge, see a charge 2 into 10 power minus 4 coulomb flows into the coil, and the resistance of the coil they have given. What they are asking here is magnetic flux pi value they are asking here. Now already you know this one about Ohm's law. See according to that Ohm's law I just mentioned here, V is equal to I into R. Now we are going to find out with the help of the charge. So according to the charge, I just make the formula here. V by R is equal to I here. See from this one again, I here is charge by time, that is equal to V by R, or even charge Q here is we can mention like a V T divided by R here. Now even a del Q, if you change this one, del Q here is delta V into T divided by R. Now this one delta V into T here is you can mention like a delta pi by R here. Now from this one you can mention here charge. See here again changing charge here after removing the magnetic field. Charge here is delta Q is equal to del pi divided by R. That one according to del pi change in flux here is change in voltage. This one voltage per time, that is about the flux here. Now delta pi values you know this one, that is NPE, and divided by R here. So what they are asking in this one, magnetic flux. See this one according to that magnetic flux B value is equal to B is equal to delta Q into R divided by N into A here. Now changing this one charge here is they have given 2 into 10 power minus 4, and the resistance here is they have given as 80 ohm, and divided by number of turns they have given as 40 here, into area here is 4 centimeter square, that is 10 power minus 4 minus 2 the whole square 10 power minus 4. See from this one you can mention here this is for 2 times. This one you can cancel here for this one time. So what you are having here is 10 power minus 4 divided by 10 power minus 4 only here. See from this one what you are having here is 1 Weber per meter square. So answer in this case 1 Weber per meter square. Okay, the next problem. A circular coil of 500 turns of wire enclose the area of 0.1 meter square per turn. See, per turn it covers 0.1 meter square. There are 500 turns of the coil. It is kept perpendicular to the magnetic field of magnetic induction 0.2, and it has been rotated a diameter of 180, along a diameter by 180 degree, and perpendicular to the field, which can be rotated to a time of 0.1 second. Then how much charge will be passed through the coil which is connected to the galvanometer with a combined resistance of both all the resistance here is, all coil resistance here is 50 ohm. This is like a similar problem what we have seen the previous one. See here the number of turns already they have given, so I just mentioned here N value here is 500 turns here, and the area what they have given here is 0.1 meter square, and it's kept in a magnetic field. They have given B value and angle. See first it has been rotated from 0 degree to 180 degree here. Now similar one previous problem we have seen the same concept with the help of the time. They have given time here is 0.1 second. Now from this one I just mentioned here, and the combined resistance value also they have given, that is 50 ohm here. Now previous you can see this one, del pi is equal to pi 2 minus pi 1. This is the concept here. In this case pi 1 I just mentioned here. Hope you remember this one, NBA cos theta and divided by r here. Now in this case we are going to mention about this is perpendicular to that axis, so we just mentioned here. So only changes here is in this case a magnetic field according to that area. This is about the dot product, so we can mention here this is about theta 1, right? Next one, similar like a pi 2 here is similar one, pi 2 is equal to NBA cos theta 2 divided by r here. Now from this one del pi I just mentioned here, del pi is equal to NBA divided by r and a cos theta 2 minus cos theta 1 here. Now you just substitute all the values. From this one I just substitute all the values. There are 500 number of turns, and a magnetic field here is 0.2 Tesla, and even area here is 0.1 meter square. No need to convert anything here, and a whole divided by the combined resistance here is 50. Now this one charge by time, over a time we got here, that is about the current which can produce the magnetic flux over here. See, that's what we have mentioned in this case. Previous problem, if you go through this one, you can understand over here. See, from this one, you can cancel it. See, zero point 0.2 into, see here, this one for 10 times. You can cancel it over here, right? And this one here is cos theta 1, that is cos of 180 degree minus cos of 0. So combined together what you are having here is minus 1, that is minus 2 here. Now this one here is 2 into 0.1 into, see, minus 2 here. So what you are going to have here is minus 0.4. So this is about see here, this is about the magnitude. In this case you are going to put this one, so that what you are going to have here is magnitude, in this case 0.4 coulomb of charge. So answer in this case, see, just go through the data, all a simple one, similar concept. A rectangular coil, see, this is till now we have seen a circular coil. This is rectangular coil of turns, 300 turns here. See, I just mentioned here there are 300 turns, and area of cross section they have mentioned this one, sorry, yeah. And area of cross section here is length and breadth they have given, that is 25 into 10 centimeter. The coil rotates 50 cycles per second, even revolution per second, rotation per second, you can mention the same one. With the help of a magnetic field they have mentioned here about the perpendicular to the axis the peak value of EMF. So the same one, EMF in volt, that's what they are asking here. See, from this one, see, I just mentioned here n value they have given, and the peak value of EMF we can mention here. See, peak value of EMF I can mention as EMF, peak value of EMF E is equal to the same one, BAN, band omega. You just remember here, in this case band omega here is, omega is about the frequency here, n is about number of turns, A is about area, B is about the magnetic field. Now in this case area here is 25 into 10 centimeter square here. Now you can mention this one, that is 250 centimeter square, or you can mention like a 250 into 10 power minus 4 meter square. Now this one, this is about the area here. And next one, omega value here is 2 pi into f. Now from here 2 pi into frequency, how much they have given here is 50 cycles per second. So what you are having here is 100 pi. So area there we found the value, and even omega value we found here. See, from this one, see, from here I just mentioned EMF, that is peak value of EMF is equal to B value here is 4 into 10 power minus 2 Tesla here, and area we got, that is 250 into 10 power minus 4 here. And next one here is Number of turns here is 300 turns, and omega here is 100 pi. Now you just simplify here. See from this one, see this is 10 power 6 I just mentioned here. So this one here is 10 power 6, and 4 into 250, that is 1000 here, 1000 into this is 10 power minus 6 here, and this one here is you are having 30,000 is there, and pi is there, 30,000 and pi. See from this one, this is 3 and this 3 together it will be cancelled here. See from this one, so 10 power 6 into 10 power minus 6 into 30 pi. So this one will be cancelled here. So what you are going to have here is 30 pi volt, that is EMF. So answer in this case, rectangular coil of a dimension 4 into 5 centimeter. Now I just mentioned here, you just consider about a rectangular coil. No, rectangular coil of length here is 4 centimeter and breadth here is 5 centimeter. So area here is 20 centimeter square with a number of turns. See here, there are number of turns here, number n is equal to 20, and place with its plane perpendicular to the uniform magnetic field. See, I just mentioned here, perpendicular to the plane, you are keeping a magnetic field here. This one I just mentioned here, this is about the magnetic field which is perpendicular to the plane, and they have given B is equal to 5 Tesla. And if it is moves with the speed of, now it has been rotating with the speed I just mentioned here, that is 2 meter per second in the field parallel to its length. Now this is length and this one is breadth here. Now parallel to its length it is rotating over here. In this case that is moving with the 2 meter per second. So here theta will be, that is parallel to it, means theta is equal to 0 here. From this one, the induced EMF is equal to, that one here is BLP sin theta here. Now this one B value is there, length is there, and the speed also they have given. The theta value here is 0. If you substitute this one sin 0 value here is 0 here, 0 with everything, that is 0 volt. So answer in this case, so the direct one you can understand here. Coming to the end part of today's sessions, where we gone through problems on electromagnetic induction. I hope these solutions help you to understand better with the key concepts and problem solving techniques. See, very few formulas are there that can be helpful for you. Even that will be very needful for you for the examination. Hope if you found this video is useful, don't forget to like, share, and leave a comments with any questions. Make sure to subscribe and hit the bell icons for more problems, tips, tricks, and even for updates. Good luck to all and for your studies. See you in the next video on electromagnetic induction, especially self and mutual induction. Thank you once again to all.